Hello everyone. Today we are going to discuss about batch simulation. Batch simulation exercise. So in this exercise, we will see how to working in a batch simulation and how to work our ladder logic diagram behind the batch simulation application. So at the first of all, we have to understood about the diagram of application. So in the batch application, we have flow meters, two flow meters. So as you can see, in the input way, we have two flow meters and two pumps. Flow meters are providing the flow of liquid. It can be liquid A and it can be liquid B. Okay, and these are the pumps. Pump are pressurized the liquid. Okay, pump provides the liquid to our tank. This is our tank, and these are our flow meters. These are our pumps, input pumps. Okay, which is provide the liquid in our tank. And after that, we have one mixture. This is the mixture. The mixture works mixing the two different types of liquid. Okay, suppose in this flow meter we have liquid A, and in this we have liquid B. So in the tank, when both flow meters are on and provide the liquid in this tank, so liquid A plus B. So our mixer, this mixture mix the liquid A and B. Okay, so the mixer works to me mixing our liquid, and this is our heater. Heater provide the heats when if you want to moving to giving the temperature, hot temperature, so you can operate your heater. Okay, heater provides the heat to burning the liquids. Okay, so heater provides the heat of our tank. Okay, and after that we have the high level sensors and low level sensor, which is detected to our liquid quantity, how much quantity in it in the tank. If our quantity is in this indication, so our low level sensor indicates the level of liquid. If our liquid are full, our tank are full from the liquid, so our high level temperature sense the liquid quantity, and gives gives the signal to our forwards instructions. Okay, so high level sensor sense the liquid in the top way, and our low level sensors sense the liquids in the bottom. Okay, and this is our the drain part. Okay, after mixing, after heating the liquid, we have to drain, we have to reserve our water in this way, from this way. Okay, after taking, after mixing, after heating, we are taking the liquid from this way. Okay, in this way, this is the output way. Okay, we can say that this is the drain way, this is the output way, and this is the outcome liquid way. Okay, this is the incoming uh, liquid way, and this is our output liquid way. Okay, outcome liquid way. So in the outcome we have one flow meter, which have to address it like that. And in the pump pump 3, we have one pump 3 in the outer side, and address is given, as you can see. Okay, so this is our application diagram. So at the first of all, this is our control panel. Okay, where we have to stable, where we have all keys like inputs and outputs, LEDs, push buttons, selector switch. Okay, so this is our selector switch. Okay, and this is our push buttons, and this is our thumb wheel, which is generally uses in the BCD, for the BCD, binary to decimal. When we are converting our numbers binary to decimal, so we are using the thumb wheel and counting the countings. Okay, it's work as a counter, counting the values. And these are our LEDs. So as you can see, this is the running LED, this is the ideal LED, this is the full LED. Okay, when gives the supply, then it will on, it will energized. Okay, so this is our diagram of the batch simulation application. And now we are going to our program. So in the program we have this one. This is our program, as you can see. This is our 24, 25 include to 0. So 25 rungs we have to discuss in our lecture. So let's start. So in the first rung we have, in the input side, in the left side, we have to added the first scan instruction. This is the NO instruction, and it's have the different name of XIC instruction, examine if close instruction. So this rung is basically to work on this statement. So three pumps, heaters, reset variables on the first PLC scan. Okay, so our PLC are scanned by this bit. This is the status bit. This S are represented to our in our data table. As we can see the data table. Okay, I will show you. When we are going to go data table, and we are just clicking on the status. So as you can see, this is the table. Okay, this is the instruction table, and when we are selecting the status file, then all the status bits are showing as our, it's depend on our application. Okay, these are our bits, these are all our bits, status bits. So as a status, so it's provide the status as a scan as a pulse. Okay, it's provide the pulses when it will take in the power supply. So yeah, so this is our status bit. It's provide the power supply to our these parts, these output instructions. So in the output instruction, in the first run, we have the the mixture timer. Okay, so we will take a timer for mixing. Okay, we can take 10 second, we can take 15 second, we can take 20 second according to our application. If we want to increase our timing for our two liquid to mix it, when our two different type of liquid are mixed, so according to our application, we can give the time. Okay, it can be 10 second, it can be 5 second, it can be 2 second. It's totally depend on our application and on self. Okay, so this is the reset bit. Okay, this is the timer address T4 double dot 0. This is the timer address. Okay, and this is the reset instruction. And in the second we have the counter reset. Okay, the counter counts the flow of level. Okay, we can take the like if you are filling the tank, so your flow meter are sense the liquid, how much quantity are flowing in my side. Okay, so after counting the liquid way, we want to reset our counter instruction. So we are taking this instruction, this reset instruction, for resetting our counters. Okay, that's why that's we will take this reset bit for the resetting our counter instruction of flow meter 1. And same things, same counter reset we will take for our flow meter 2. Okay, we have three flow meters. One is that flow meter 1, flow meter 2, and flow meter 3. Okay, which is located in our output side, outcomer side, and these are connected to our incomer side, where when our liquid are coming, so this is that side. Okay, and the tank level. So from the tank level, we have also added the counter, this address counter from this address, and we will take a reset bit for the resetting the value, all values for this counter. And we will also take a one another counter which is have the different addressing, which name is batch count. Okay, batch counts. So batch counts is depending on our batching counts. Okay, it can be like liquids. It's totally depend on our liquids. And after that we have to mixing cycle. So this is the unlatch. Okay, so as we have to discuss in our course, we have already discussed about the latch instruction and unlatch instruction. So I hope you will you have to remember that all things, unlatch and latch things. So this is the unlatch instruction, which is unlatching the mixing cycle. Okay, after mix the cycle, the mixer by the mixture, so it will stop this mixture with this instruction. Okay, and this is the unlatching instruction for our drain cycle. Okay, drain cycle, it's depend on our like this side. This is the outcomer side. Okay, this is the drain side, and this is the incomer side. Okay, so as you can see, the drain cycle latch instruction uses for this side. Okay, and the set point 1 reached. So this is the, as you can see, B. Okay, B is the binary. Okay, it's this bit is generally used for the internal bit. Okay, it's haven't connected to our physical. Okay, it's doesn't connect it to our physical way. It's are our internal bits. Binary bits is our internal bit, memory bit. Okay, it's just like that switching for on off and controlling the way of inputs and outputs. Okay, and this is the using for our set point 1 and set point 2 reached. Okay, set points, what is the set point? Set point is the value where our liquid are reached. If our liquid are reached to our bottom side, so it will like that it shows like that finish. And when our liquid are reached to our full above the tank, so it will indicate the full of tank. Okay, the quantity are full in the tank, it will show. So this is a set points, the value of our liquids quantity. Okay, and in the next rung we have okay, yeah. So in the next rung we have the system run, relay and lights. So this is the run light. Okay, so in this rung we have this rung light. This address is that o double dot 2/5 system run light. Okay, this is the system run light. When our system are running, during the running, it will show, it will energized, it will turn on during the running condition. So in this rung, we have to connect it. The one is that stop push button, and that is one auto stop button. Oh, okay. This is the internal event. Okay, auto stop. It stopped the automatically if you are going to selected. You select the auto mode by using the selector switch, so it will stop the automatic. Okay, and after that we have to connect it the start push button, and this is our holding. Okay, this is our holding, so it's a hold. This address and this address is same. Okay, this address and this address same, but here we have this input instruction, and here we have to our output instruction. Okay, and in the next run we have like that. So in the next run we have the system run lights. Okay, the system run lights have the addressing of our output like this one. Okay, this light are addressing having this instruction, and its instruction are providing the supply of our output 6 to output double dot 2/6 standby light. Okay, and our standby light, this one. Okay, this is our ideal light, standby light. When our whole system are stopped condition, so it will show. Okay, ideal show, ideal light, it will glow, it will turn on when our whole system are stopped. And after this rung we have this rung. So this rung have if, read the statements, if enter push button is not on, read 1 double dot 3. Sorry, this is the I double dot 3 input 3 as desired batch count and move to counter C5 double dot 4 ACC. What is the ACC? So ACC here ACC is accumulated value, which is in related to our counters. Okay, so we have already discussed about the counters, timers, and all types of parameters, all types of bits. So you can, I hope you have to remember all things, all previous things. Okay, so this is our input instruction and no instruction. Okay, this is our and no instruction, and here we have to put the addressing of this I double dot 1/8. So where is the this address? So this is the enter push button. Okay, enter push button. So when you're going to your cursor on this, so it will show. As you can see, it will show the addressing I double dot 1/8 NOPD. Okay, so this is the same address of it. Okay, this is the button and address is here. Okay, enter push button, and this is the FRD instruction basically used to our converter, BCD converter. Okay, it's convert to our binary to decimal numbers. Binary to decimal numbers. So as you can see, it's have the source. So this have FRD instruction have source and dest parameter. So this is a source parameter, and this is the destination parameter. Okay, so destination means that where you want to provide your value. Okay, this is the destination value. So in the source value we have this address. This address is our this one. Okay, this one. This is our batch mix simulation. Okay, this is the thumb wheel. So I will show the changing parameters like that. Okay, it can be changed according to our application and demand and project work. Okay, so when you are going to this display, so it will show the output for BCD, binary to decimal, binary coded decimal. Okay, and when you are going to move this cursor on the thumb wheel, so it will show the input double dot 3 and BCD. Okay, so this is the thumb wheel. So in the thumb wheel we have added, we have to fill the input address, and in the destination parameter we have the counter preset value. Okay, so this is the counter preset value, because our thumb wheel it's counts the counting. Okay, counts the counting. So this is the counter value. This is the counter value preset value. So it's totally depend on our input 3, which you have to enter in this parameter. So it's totally depend on it. Okay, this is our source value, this is our destination value. This is our thumb wheel. Okay, in the next rung we have, if enter push button is on, read input double dot 3 as percentage of 100 and compute flow meter one set point equal to percentage multiply 306 upon divide 100 equal to I double dot 3 into 306 divide by 100. Okay, this is the formula of the putting the values. Okay, so in this one we have in the left side we have to connect it the input instruction. So input instruction is our like that. This have to this addressing. Okay, enter push button. This is the enter push button, and this addressing is filled to here. Okay, and this is our FRD instruction. This is the same. This is the same FRD instruction, but here we have putting our source addressing same and source addressing same, but in this FRD instruction we have to fill our counter preset value addressing, and in this FRD instruction we have to fill in the destination parameter, we have to fill the integer value. Okay, integer value. When you want to controlling all the kind of things, so you can use this bit addressing. Okay, this is the integer value. Integer value you can take from the go to data table, and you can choose the integer. Yeah, integer bit. Okay, so as you can see, this is the 7 double dot 0. It's totally depend on your things what you want to choose. Okay, whatever you can choose according to your needed. Okay, this is the integer addressing table. Okay, so this is the same thumb wheel, and this instruction is our multiply instruction. Okay, when this is integer, yeah, this integer bit having the number, so it will transferring to this instruction. Okay, if suppose if our here we have the five number we have in this integer value, so it will also show the 5. Okay, this is a same, this addressing and this addressing is the same. Okay, okay, this is the same in the source a. Okay, multiply have two source, this one and this one, source a, source b, and our destination. Okay, destination is the total of this source a and source b. Okay, total multiply of our source a and source b. Okay, so in the source a, if suppose 1. Okay, the integer here in the destination value we have the first one value, so it's transfer here, it will show the 1. Okay, and here we have to also put it 306 value, so it's the multiply of the two source a and source b, so it will show 306 in the destination value. Okay, so this is our multiply instruction. This is our destination value, which is showing the total of this source a and source b result. And after that we have to connect the divide instruction, division instruction. Division instruction also have the two source values, source a and source b. So in the source a we have to put it this integer instruction, and in the source b you can take 100, you can take 50, you can take 1, according to your calculation you can take whatever you need it. Okay, and in the destination value you can put another integer address. Okay, and after the instruction you can connect the in the parallel, you can connect the move instruction. Okay, move instruction is the moving the numbers. Okay, moving the values, moving the value. If your final value are coming in this integer instruction value. Okay, this is the integer bit. Okay, so in this bit you have to collect the final value. After this all process you will collect the final value in this integer bit. Okay, your integer bit are transferred to same here, this is in the move instruction. Okay, and in the move instruction moving your integer value to our counter. Okay, to our counter value. Okay, so in the destination you have to put it the counter preset value, and the counter, this counter preset value are sensing this value. Okay, it shows this value. If your value is coming 2 in this source, so it will also showing the 2. If it will show the 100, so it will also showing the 100. Okay. Okay. So in the 5 number rung, we will see, look at the tank level set point. Latch on B3 double dot 0/2. If the flow meter 1 is equal to or greater than, so integer n 7 double dot 2. Okay. So as you can see, this is in the move instruction, we have this same instruction, and is that our same instruction. Okay. And here is the controlling of the level. Okay. So in the tank, you will control the level of the liquid. So that's why you will, that is the method to controlling, and you are using this instruction bits. Okay. So in the 5 number rung, you have to connect it. One thing is that instruction. Okay, this is the NO instruction, and you have to put it the output bit address. Okay, this is the system light. Okay, light run, when your light are turned on, so it will gives the supply of our great instruction, and greater than and equal instruction, and after the computing this address, it will provide the power supply to our latch instruction, latch output instruction. Okay. So GEQ, greater than and equal to instruction, have two parameters, source A and source B. So in the source A, we have the putting counter accumulated value. Okay, counter 5.1 addressing number instruction to the counter, it will have the accumulated value in the source A, and in the source B we have to put it the integer value. Okay, so our source A and source B, source A value greater than and equal to the from to the source B, so it will passing the signals. Okay, it will passing the signal, otherwise it will stop. Okay, so after passing the signal, our latch instruction will get the power supply and provide the signal in the physical way, in the hardware. Okay, and the error detection in the next rung, we have in the 6 number rung, we have the error detection. So if tank level set point is 0, not set it, then look at the tank level counter. Okay, if equal, so you have to manually put in the 0, and in the source A you will put the integer n70. Okay, so we have this one in the multiplication and destination parameter of our BCD, binary coded decimal. This is the integer first 7.0. So same integer we will put in the equal instruction. Okay, and in the opposites, in the source B, we have the zero value for the comparison to our this instruction. Okay, and after that we will connect it to the input instruction, that is the NO, and have to putting the counter 5.1 instruction of the DN bit. Okay, and this counter is used for our flow meter 1 for setting the point. And in the right side, in the output side, we have to connect it the one latch instruction, latch output instruction, where we have to put in the binary instruction. Okay, this is our set point 1 digit value.
The next one we have to connect it the statement, as you can see, read if input double dot 1 by 8 is on, then compute set point 2 equal to 306 minus set point 1 equal to 306 minus n 7 double dot 2. Then the left one we have to connect with the enter push button. Okay, when you are pressing the enter, okay, yeah, once you fill the parameter like that 300, and after providing the data to our thumb wheel, so you will fill, you must be to fill. So after for the filling the value in the thumb wheel, you must be click the enter from this button. Okay, so that is the matter here. This run is says that enter push button. Okay, so this is our enter push button, and this is the subtract. Okay, the subtract instruction have the same source A and source B, and same the destination value. So our source A value we have in the manually we have to the 306. You can take in any other what you want to. Okay, and in the source B we have to connect it the other integer value, and in the destination we have to a different integer value in the new integer value. And in the move we have to connect it one parallel instruction which name is the moving instruction, move instruction. So it this move instruction transferring the data to source to destination. So in the source value we have to the integer value, and in the destination value we have the counter reset value. Okay, that counter is the different, and our previous run counter is that different. Okay, and in the 8 number run we have look at the tank level set point 2 latch on binary 3 double dot 0 slash 3 if the flow meter is equal to or greater than n7 double dot 3. Okay, so in this run we have to connect it the system run light. So this is our system run light, this is our system run light, and this is the same addressing here. And after this instruction we have to connect it the geq greater than and equal to instruction if our source A greater than to or equal to our source B. Okay, in the source A we have to put in the accumulated value of this counter, and in the source B we have to connect it the integer value of 7.3. This is our tank 2 level display. Okay, and in the right side we in the output side we have to connect it the latch instruction. Okay, with the binary bit. As we know, this is the internal bit. The binary bit is our internal bit. And in the 9th rung, error detection. If tank level set point is 0, not set, then look at the tank level counter equal to. So equal to our we have the source A and source B. So in the source B we have to put it the 0 value, and in the source A we have to put a new integer value. As you can see that n7 double dot 0. Okay, this is our first new integer value. And after the equal to instruction we have to connect it our flow meter to set point. Okay, flow meter to set point, and filling the address of our counter done bit. Okay, done bit counter we will fill in this for this instruction. And in the right side we have to connect it the set point to reached. This is a latch instruction. Okay, And this is our in the 10th rung. We have to connect it to the controlling part. Okay, in that controlling part, we have to connect it the system rung light instruction address for pump 1 motor start. This for this flow, we will make this rung. Okay, if you for the working of this way, we will making this controlling of our instructions. Okay, so in this instruction, so in this in the 10th rung, we have to connect it in the first way our system run light. Okay, so our system run light says that to this one, our system run light, this is our light system. Okay, and after that we have to set point 1. So this is our binary, this is our binary bit. Okay, this is our internal bit, and in this is the mixing cycle. So this is our also, this is our also binary bit, but different address. As you can see, 0 slash 0, 0 slash 2, 0 slash 1. Okay, this is our drain cycle. So this is our drain cycle, this is our mixing cycle, and this is our set point 1 cycle. Okay, and this is our run system. Okay, and tank high level. So this is our tank high level sensor, and in the output side we have to pump 1. So this is our pump 1. So pump 1 are included in our output. Okay, output side. So in the 11th rung we have to same process for the pump 2. Okay, our previous rung for are controlling for our pump 1, and the 11th rung will control our pump 2. So this is our pump 2. Okay, this is our pump 2 and controlling for from this rung. Okay, so same, we will connect to the system rung light, and set point 2 reach, and mixing cycle and drain cycle and tank high level sensor. Okay, so these are we will take as a NC instruction. Okay, and this one we will take to NO instruction. Okay, and these are our taking as a NC instruction. Why we taking the NC instruction? Because the level sensor, our sensor are switching like a NC. Okay, like a NC. When it will sense the liquid, so it will, after sensing the liquid in the high, in the above, in the upper side level, so it will gives the signal, it's provide the signal, it's cut off the signal. Okay, that's we will taking here NC. Okay, and these are our internal bits. So as you can see, and in the right side we have to connect it our pump 2. So this is our pump 2, and in the 12th rung we have to read it, when level greater than 10 allows faster heat up, and thermostat, this is our thermostat, this one. Okay, this one is our thermostat are it's we can say that measuring, it's measure the supply, it's measure the humidity. As you can see that the temperature range. Okay,
It's the thermostat measure the temperature value. Okay, if as you can see, this is the thermostat panel. You can increase and decrease your values. Okay, if you want to read out and controlling like 25 degrees Celsius. Okay, so it will count from the 55 and it will slow, it will stop after this the value of 25. Okay, so this is a thermostat which is measure the sensing the heating capacity of the liquid in the tank. Okay. Okay, so this is our rung 13. Okay, and in the rung 13, okay, rung 12. Rung 12, we have to connect a greater than instruction, and in the greater than instruction in the source A, we have to connect it, the counter accumulated value, and in the source B, have to connect it the 10 value. Okay, 10 manually value, because here we have to connect it greater than 10. Okay, greater than 10. And this is the thermostat sensor, and in the right side we have to our tank heater. So this is our heater, this is our heater, and this is our heater addressing. Okay, and this is our thermostat controlling this one. Okay. Okay, so in the 13 rung we have this the fill step tank level, flow meter 1 pulse. Okay, this is our flow meter, and this is the CTU. Okay, so in the previous rungs we have already discussed about the counters bit. Okay, so the counter bits are comes from this and this counters. Okay, this counter is used for our flow meter 1, and this counter is used for our flow meter 2. Okay, and as you can see, this have the addressing of C5.1, and for flow meter 2 counters have the addressing of C5.2. Okay, and the flow meter 1 counter have the 306 reset value, and flow meter 2 have the 0 reset value. Okay, if not in drain cycle, then add flow meter 1 and 2 together to get total level. Okay, so in the drain cycle, this is our drain cycle, and we have to created the internal bit like a binary for the controlling this way, and in the right side we have to connect it the add instruction which is adding the two values. Okay, so here suppose here we have to taking we have to take the liquid from flow meter 1 as 50%. Okay, and we have to also taking the 50% from flow meter 2 this way. Okay, so this way we have to taking the 50%, and this way we have to be taking this 50%. So it's adding and making 100%. Okay, so the quantity is that 50% and the quantity is that 50%. So total quantity of the liquid in the tank is that 100%. Okay, 100. So this adding instruction works and joint to the to our flow meter 1 and flow meter 2 values. Okay, and in the 16 rung we have to connect it the tank level draining for the draining. Okay, flow meter 3, as you can see, this is the flow meter 3. Okay, this is our flow meter 3, and same addressing here, and this is already working for our the CTD counter down. Okay, and here is also that you can see This is our CTU, counter up, counter up, counter up. We have to discuss, we have to use the flow meter 1 and 2, the counter up, and for the flow meter 3 we have to use counter down. Okay, counter down. So after releasing, after draining the liquid from the tank, so it will reduce the values. When your values are reached to over 360 after filling the tank, so it will reduce. When your liquid are going to outside from the flow meter 3, so it will reduce the liquid. Okay, so that's where we have to use, where that's counter down are working. Okay, for reducing the level of liquid. And in the next 17th rung we have to take level display. So this is the BCD, binary coded display, binary to decimal display. So in the source value we have to put in the counter accumulated value, and in the destination we have to fill the output 4. So as you can see, this display, this is the output 4, as you can see. Okay, O double dot 4 BCD, binary coded decimal. Okay, this is the display. Okay, so here we have to put this address for representing our tank level quantity. Okay, and in the 18 rung we have the tank full light, and tank full light, this is the tank high level sensor. Okay, so this is the for controlling the holding. Okay, and the mix setup, if a tank is full of set points 1 and 2 are reached, then start mix cycle. And in the for the cycle setup, set point 1 reached and set point 2 reached, and if both are reached, then our mixing cycle are running, and the tank high level will sense our the mixing cycle. And in the 20th rung we have to discuss, we have to controlling the mixing setup. When our two different type of liquids are mixed, so these rungs we will use for the controlling of mixing. So this is the um, no instruction, and we have to put in the output address for controlling. And after that we have to taking a one another binary bit for the mixing cycle. And in the output side we have to connect it one RTO is the retentive timer on, and a retentive timer, as you can I hope you have to remember the RTO. Okay, from the resetting we have to taking the reset bit for the clear all the data of this timer, retentive timer on. Okay, the have the timer address like that, e4 double dot 0 time base 0.1 and preset value 40 second, and accumulated value 0. Okay, mixed timer. This timer is work for the mixing. Okay, we have to taking the 40 second for the mixing. Okay. And it can be increase and decrease time according to your application. You can take the 10 second, you can take the 15 second, you can take the 2 hour, you can take the 1 hour. Okay, and here we have to connect in the tank heater. Okay, tank heater NC instruction are using here. And in the mix timer, this is the timer DN bit. Okay, done bit. So this is the same address and this is the same address, so same address bits are working here. Okay, done bit. After done bit are energized, so it will stop the tank mixer. Okay, and in the 21st rung we have the drain step, latch, drain cycle, relay, system run light, and after that you will connect it to mixture time. So DN bit you can use for this input instruction, and the drain cycle in the output side. This is our latch instruction, and drain setup start pump 3. Okay, from start pump 3. This is the start pump 3. As you can see, this is the start pump 3. This is the start pump 3. Okay, it's used for the draining our liquid. Okay, and in the first way we have to connect it the system run lights, output instruction address, and tank low level sensor instruction input, and in the input instruction with the binary internal bits. Okay, it's used for drain cycle. Drain step at the end, or drain cycle increment batch counter C 5 by 1. So system run light we have to connect it as a general, and the drain cycle is the internally bits for connecting to our inputs, receptor to switching the CPU. Okay, and liquid instruction, and less than equal to instruction, and counter up instruction. So in the less than or equal to instruction, we have to two source parameter, source A. In the source A, we have to putting the counters accumulated value, and in the source B, we have to putting the zero value. And in the parallel way, we have to connecting one tank low level with the help of NC instruction. Okay, and in the right side, we have to connecting the counter instruction. And in the 24th rung, we have to restart, reset your all kind of instructions. Okay, once you need to restart your old instructions, so must you need to add this type of instruction in your program. Okay, so in the left side we have to connect it, the system rungs as you the output, and in the drain cycle the binary, as you can see, and the less than or equal to instruction, you will also um, you will also use for the less than equal to. Okay, and you will use the counter accumulated value in the source A, and source B will controlling the zero value. Okay, so in the last one we have these of instruction. So in the last we have to less than or equal to, less than and equal to. In the source A, we have to fill the counter accumulated value, and in the source B, we have to connect with the zero value as the main value. And in the parallel connection connected, we have to the NC instruction of our input low level sensor. And in the output side, we have to connecting all these of our reset button. Okay, so reset output for our mixer time, and reset output for our flow meter 1, reset output for our flow meter 2, reset instruction for tank level, and the unlatch instruction for our mixing cycle, and the set point 1 instruction, unlatch instruction, and unlatch instruction for set point 2, and in the selector switch A 1 batch, and auto stop it will binary internally bits for controlling the outputs, and the selector switch B the multiple batch, and the batch count done, by counters, and the unlatch of our drain cycle. Okay, drain cycle are unlatched with this instruction. And in the last rung, as you can see, this rung is shows the ending of the program. Okay, so this is our whole program we have to discuss. And now we are going to online with our program. Our program are downloading in the PLC, so it's taking some time to scanning all types of inputs and outputs parameters. Okay, so it has to connect it. Yeah, so when you're pressing the start push button, okay, from the pressing the start push button, we must to go to the run mode. And when you are clicking the run mode, so our ideal LED will glow. Okay, so when it will glow, and okay, when you are pressing the start push button, it will reflect like that. And as you can see, you can increase your temperature level from the thermostat. And after reaching this level, approximate, after reaching the temperature level thermostat, it will mix the liquid and drain automatically. When you are going to B manual and give the starting, so as you can see, this is the flow meter one. Only flow meter one are working in the B selection mode. Okay, and our mixer are worked, mixing the liquid according to our time. You can increase it according to your application, and after that it will drain the all liquid from with the help of pump 3 and flow meter 3. Okay, if you're pressing the C and enters, and you can increase your temperature with the buy of thermostats. As you can see, this is the display of BCD. Okay, it's decrease, increase. Okay, it's increasing, it's decreasing according to our counters. This is the working according to our timers. Okay, this is also connected to our counters. As you can see, this is the BCD. Okay, as you can see this, and this is the automatic turn on. And when you're selecting the A, and you can best simulation thumb wheel, you provide this value and enter, then you will start the process. And it's also working. You can decrease your temperature. Okay. And enter the start. Okay, it will fill, and your high level sensor sense the liquid when it will reach at the high, and your low level sensor will sense the liquid when it will bottom. Okay, so this is our application according to our project. Okay, according to your working parameters, you can select it. Okay, thanks for watching this lecture. If you have any doubt, any query, so you can freely ask to me. Okay, as you can see, this is our BCD converter. This is our RTO. This is our add instruction. Okay, all these things. You can increase the velocity of the entering. Okay, the A selector switch, it's done manually. If you are going to B and C, so it will automatically work. Okay, so this is our batch simulation. Thank you for watching. We'll meet as soon in the next lecture. Thank you.